So who is VMH? We obviously represent the Siemens PLM software suite. We're a platinum reseller for Siemens, and we have support. We have guys that handle any kind of technical issues that you guys may have or questions or whatever it may be involved with software. We do training, whether it be on-site, off-site, or we can also send you to the Siemens PLM direct classes. We have something called a dream team, just some young guys that are engineers that solve issues and problems that we have aboard. And we have mentoring, which is we come on site, we take a look at what you're doing, kind of stand behind you and make sure you're doing all the right good things. These are the industries we typically focus on: aerospace, automotive, electronic, medical, and machinery. We do step outside the boundaries, do a lot of job shops. So, but most of them fall within some categories, and you guys probably do work for some of those or make parts for those. Those are our core industries. The nice thing is we do have, we were one of the first vendors or these partners to partner with Microsoft on the cloud-based Team Center product, which seems to be a huge advantage. And obviously we have a mobile training center. We can bring laptops on site. We work with technology partners, whether you guys are buying Mazak, Makino, the Pumas, we have posts and machine simulation developed already. Supplier programs, we work with GE Aircraft, work with different suppliers to get them software so they can integrate better into the OEMs. And vast industry knowledge. I've been doing this 16 years. I've got a lot of knowledge of, I came out of college with basically a quality degree, any kind of inspection, anything to do with engineering. But I've been doing this 16 years, worked with a lot of owners, a lot of private equity guys, and I'm just always looking for better ways to improve the process, and that's why we're having this conversation today. Next slide. Why would anybody look at CAM? People don't realize that formal Unigraphics now, Annex CAM, we've been around. It's actually over 30 years, probably 35 years down the make auto days, McDonnell Douglas. The first programming language was UNIAC, so it came out of a CAM package. We built CAD on top of CAM. That's why our CAM is so amazing. We've got 14% of the market share. We're probably number 2 in the world as far as the market share on the CAM side. We've got a great Annex CAM product. Got a lot of users, a lot of successes. We'll talk about those. And we got a wide range of machining capability. We can do mill turns, 3 to 5 axis milling, wire EDM, or lathe. We do have a global presence. We're in almost every country, and 40,000 installed seats worldwide. These are some of the industries we do real well, and you guys are probably familiar with doing mold and die machining, which is complex surfacing, prismatic parts for round parts, simple parts, and complex parts. As you see that turbo machine, that blisk right there for any kind of medical device, power generation, or you see aerospace cutting those large turbine blades. We have a complete system, so you can, as you see on the left-hand side, all the different modules that we have or pieces inside the Annex CAM. We do have templates and everything written for each one of these things, but there's a lot of features and capabilities of each one, and each one has its positives. Whether you're punching 2D holes through plates, or some of you guys are, you're doing 3-axis contour machining, doing a core and cavity mill, whatever you're doing, we have different applications for each application that you guys have. Next one. So 3-axis milling, typically that's, unless I run into more often than not, and a majority of the time that you guys spend is hogging out the material, as you see there in the center where that tool's at. So we want to focus on how we make you guys more efficient and better at what you do. Obviously, Annex CAM, we can program this, and obviously programming time and how you approach the type of material you have with the type of cutter you have. There's strategies with all this. We want to talk about the strategies towards the end as far as what tool you use or what machining technique. And every machining technique doesn't necessarily mean it's bad, but everybody does the software its own way to make it work. But we'll see with the volume mill and with their approaches. Next slide. So you see typically when you're roughing out material, we were the first ones to come out with high-speed milling, which is the NURBS, the non-uniform rational heat spline information, which basically is just saying, hey, if you go into a 90-degree bend, let's smooth the tool path out so it doesn't go fast and then slow down and then go fast, which is bad on the tool and bad on the machine and bad on everything. Automatic in-process workpiece. So the IPW on the workpiece basically keeps track of all the uncut material. And then for Codal, you guys are familiar with that particular method with You can kind of ramp in at a circular movements, and then come back out and hit it again with circular movements with cutting size of the tool. Next slide. We just talk about safe cutting. I have a lot of customers asking about this too. You know, how do I know if I have a forward collision? Now we have a way of detecting this. We can also report the minimum length of cutting tool. So if you're doing a certain depth, you'll know how deep you can go with a minimum cutting length tool before you bang in the material itself. Next slide. Plunge milling, high volume material removal rate. Use the shortest possible cutting tool. So when you kind of plunge milling, you want to make sure that you're covering, you're not banging your tool or into your part and destroying your part. And I said that control the process workpiece and process workpiece, which, because I know where the geometry is at, I'm going to leave a certain amount of material. You know, the tool knows exactly, and the Toolpath knows exactly what's going to hit on the next pass. Next slide. Rest milling. A lot of you guys do rest milling operations. Leave constant material for the next cutting operation, which is what you guys want. You don't want to see a big chunk of material you weren't ready for. Next slide. And then I mentioned the high-speed machining. As you see the circles there, as you can see, it kind of comes in a circular removal rate. So your chip loads and material thicknesses are all remain at a high rate, at a consistent speed, and stay, you know, in the part, cutting the part, and making your part, which is how you're going to make money. And the non-cutting moves and all the moves moving around are all the ones where you lose time, where you're not cutting material, which is a waste. We're trying to get all those out of the operation. Next slide. So we have specialized tasks. I mean, this is a high material removal rate. We have all these kind of things that, you know, chatter-free machine parameters. You guys don't want any chatter because you don't want to get faceted side parts. So for coil milling, for consistent tool loads, so you know exactly what the tool is going to face when it goes in the material, when it comes in and out of the part. So there's all kinds of new things and new advantages, new intelligence we build into the software. And then finishing, you guys care about finishing. You want to make sure you get smooth engages, retracts, step overs, whatever control you want to have to finish the part. So you either don't have to hand polish it, or you can get it right off the part. I've seen people do it right off the part and be a good part. Next slide. 5-axis milling. A lot of people are getting into 5-axis milling. It reduces your multiple setups, which rolls back into reducing your machine time, right? When you got to do multiple setups, you got to do multiple fixtures. There's all kinds of stuff that goes into that. We do 5-axis extremely well. I've done a lot of different customers. A lot of people position the 4th and 5th axis, but we do true 5-axis milling. Next slide. This is a new module. I won't go into in great detail. It was specifically written just for the blisk industry, just for the aerospace industry, because they were asking for this. They were using a product called NREC, which is an older product that does bliss. But now we're able to use this, and it basically is it's basically a wizard. You just pick the splitters, the hub, the blades, and tell you how many inches around the blade, and it programs it for you. Next slide. Wire EDM. This is another integrated piece of the package. Next slide. Turning. So as you can see, we have a full manufacturing suite capabilities. Next slide. And then mill turn. You know, you guys doing some milling, some turning. A lot of people are getting into mill turn operations with multiple turrets. Go ahead, next slide. Synchronization manager, that's how we sync the heads. You're basically posting out a lathe program and a mill program, and you're integrating them together to make sure the speed of the feeds all sync up. You obviously want to do that when you're machining multiple parts. Next slide. So the feature-based machine, people always ask about that. Is it going to recognize holes? Is it going to recognize certain features? Yes is the answer. And it's getting more and more powerful each day. So you see a hole with a ½ inch, it knows the depth, it knows, as long as the solid model is intelligent, it will pick up all that intelligent data. Next slide. And a lot of people are driving the PMM. I see this more often than not. Driving the PMI data for your CMM programming, so it picks up all those PMI information that's embedded in the model itself. So I mean, it's a nice way of just having everything driven through the PMI to make sure you're staying in tolerance. Next slide. Templates. I'm real big on templates. You know, why this is part of your savings. Why reinvent the wheel? Once you do an operation, you know your speeds and feeds, you know your spindle speeds, you know the material you're cutting, you know what cutters you like, you have your standard cutters. Why reinvent the wheel? Once you develop a part, once you program a part, why not copy and paste to the next operation, and then you can just adjust your different geometries or whatever else on that part. I see so many guys reinventing the wheel, going through the ladder, as I call it, and it just takes too long to pick all those pieces. I would just copy and paste to the next operation. That's where Barry has been so successful. Next slide. So your machining data library. So on those end mill, it tells you what kind of material you're going to cut, and then they tell you, it basically tells you any intelligence that you would need to know for the type of steel you're cutting. Like if you're cutting hardened P20, you're cutting D2, A2, any kind of hardened steel, it's going to have all the intelligence built into it. And keeping track of all this, it make your life a lot easier. Instead of going to the tooling vendor saying, what type of material can I cut, how many flutes do I need, how big of a tool, you can use standard tools to do all these different things. Next slide. So we got library, machining data library enables you to basically manage your cutting conditions. And you guys are probably cutting similar materials each time, but you want to do them more efficiently every time. And you certainly don't want to be dry running machines or testing out G-code when you guys can be cutting parts. You could use simulation like a beer cut package where you're doing offline testing of your programs and not dry running your machines, which is another savings. Next slide. Post-processor, you guys care about that, whether you have a Mazak, Makino, Hardage, whatever you may have. We have a post library. You can either build your own posts, or we have posts online, or we can develop the posts for you. Whatever it may be, we have access to post processors. You can do outside. You can go to ICAM or InterSim. They write external posts for the post processors as well. So you have some different options to get your data out to the machine. Next slide. So this is just basically the library that we have of the post library for the posts. And this is probably the number one question people have when they buy the Annex CAM piece is, how do I make this more efficient? And if you have an existing post today, how do I optimize my data that's coming out of my post? And we can help you with that as well, too. Next slide. And then a lot of these guys, I know Barry uses this for his setup sheets for shop documentation. And the guys on the floor want to know a T01 or T02, T03, what kind of tool it is. Barry defines all that for his purpose. So they know a T09 is a 5/8, I mean, for instance. So they know what they're looking at on the floor. It also keeps track of the IPW, so the guy knows when he gets to a semi-finished operation, what's this part look like. If it's something out of whack, he can say, wow, it doesn't look like a photo. You know, this guy's on the floor, like I see different things. It can be an HTML base. They can click on this, and they can have an interactive live viewer. But it's really endless, and you can customize it just for your shop floor. You could have XYZ, custom job shop, you know, cutting part 1, 2, 9, 10. Next slide. Ease of use. All these play into, I know that we're talking about reducing machining, but ease of use, you want your guy to not use it for a couple of days and come back and know exactly what to do. We're trying to make the interface a lot easier, the menu's a lot easier. We talk about templates, we talk about all the important things. All these play into making you guys more efficient. Next slide. The advanced user interface. So, you know, you always want to think about, you know, command finder. So we have different tools to make things go faster for you. So say you want to create a tool, and you're like, where's the create tool at? Well, you go to command finder, type in create tool. So with the interface, we're allowing you to make your jobs go a lot easier with the interface that we're taking advantage of, and you can find different things because we do so many different things. It's just easier to have a command finder. You can go out and find stuff. Next slide. So workflow materials. So any kind of tutorial that you want to use for your guys that, hey, I'm gonna cut. I haven't used it yet. I want to do an aerospace part. It's going to walk you through a workflow tutorial. Quickly get them up to speed. It actually works very, very well. And you can also use something called Learning Advantage, which actually gets them up to speed pretty quickly. Next slide. Let's hit the button again. Okay, this is a good one. So getting into volume mill. What is volume mill? Volume mill is a package that can run on top of Mastercam, Gibbs, you name it. The external CAM package, you have to ask me, and I'll make sure it's on the list. You can run a product called Nexium. Nexium is an external package that runs with volume mill that helps take a Toolpath and make it more efficient. And the second thing is it runs aside as an icon inside Annex. What does it do? Roughing operation. What's the majority of your time? Roughing the material. And I hear guys have taken, you know, they could take 10 thou off a part up top, or, you know, that's a cut that we're taking with this, or inch and a quarter at max, you know, max speeds. So we're able to use the side of the tool instead of the bottom of the tool. So like an end mill, we're using the flute length to cut the part. It's a new, different way of thinking. Every time someone shows someone the part, if they're cutting it, I did a test cut at SC tool mold. We went from, one part went from 8 hours and 30 minutes to an hour 10, which is significant savings, but it was a whole new methodology, and they're getting 4 times tool life out of those tools. So the thing is, we're talking about reducing machine time. What does that mean? It means if you have a CAD system and a CAM system that's integrated, that's going to play into it. How do I set up a template? How do I make things easier? How do I keep track of the standard tools I use? Because the more standardized tools you have and not specialized tools, you're going to save yourself some money. And then on a time savings, how do I optimize my toolpath and optimize my machine? Because every machine runs at certain RPMs, certain inches per minute. But, Volume is so smart with a milling advisor that you would download. You type in, like I say, a Hardin P20. I'm cutting with a 5 flute, 30,400 radius tool. It knows I can go 400 inches a minute at 4,300 RPMs. And that's how smart it is. Next slide. So these are some of the guidelines. Hit the button again. With inch per tooth, depth of cut, all these play into the algorithm that goes into the toolpath. The toolpath that they use is you're basically cutting with the side of the tool at a 7 to 15% step over with a 5 flute tool. The tools are pretty cheap, comparably to an insert tool, but they're getting a lot of tool life out of that. We'll talk with Barry about that. Next slide. Why volume mill? I've been selling volume mill for over a year now. To be honest with you, I didn't know that I believed it in the beginning until I saw a part cut at AFC Tool. When I saw the part cut, I thought, wow, there's a lot of time that's spent, hogging material out and very conservative ways of machining. But no one has that advantage anymore with the overseas competition. You got to make things quicker, faster, optimize tool life, and you just don't have the opportunity to machine the way you used to machine. So I saw this, and I thought it was an opportunity for American manufacturing to take advantage of this new technology. For $5,000, and it's going to literally its payback is 2-3 days on some of these jobs I've done. It's inexpensive. It's simple. Literally, if Barry spent a half hour with you, an hour, you're going to grasp what he's saying and what he's doing. It's unobtrusive. It runs inside NX Cam, NX Express. It runs external to GIFs, and whatever you may be using, it will work. It has an immediate impact in ROI, which means, if you're machining an 8-hour part in an hour, it doesn't take you a while to figure out that you're saving a lot of money. You're able to quote jobs a lot cheaper. I've been doing this a long time. I've seen volume will save you a lot of time. The way you approach the machine operation, having the operators believe in the process in which they're not cranking down feed rates, or that's what kills everybody. Is they're getting conservative, and I want to take an inch depth cut. I want to take a 1/4 inch depth cut. So you got to kind of trust the software and what it does. Next slide. So let's get Barry on the phone here. Let's have a little conversation with him and ask him a few questions.
How you doing, Doug?
Hey, Barry, how are you?
Doing fine.
Glad you can join. As you know, I've been calling AFC Tools since 2005, and I sold some of the first seats to Rob Kyra. I think you were joining the board just about right then. You guys have come a long way. I think you agree with that. Why don't you explain where they were in the beginning and where you are now? Because I think that's a drastic difference. And I want you to talk about what Volume Mill has added as an additional icing on the cake, so to speak, for the NX Cam.
Well, within the last 5 years at AFC, we've gone from sending out any type of detail that we had to do that required the machine to move in 3 axes, i.e. X, Y, and Z, to adding first a mid-size Herco, a 3-axis machine, and then next we added a large Herco, basically a 64-inch X-Travel with the addition of a 4-axis. And then to our latest, we have a 3-meter bridge-style 80-horsepower Herco, capable 4-axis also. So now instead of sending work out, we are now bringing work in from other shops. Using the Annex software, we're now able to take the customer's complex geometry, program to that geometry very easily, and also find tooling around that geometry relatively easy. So we basically, in 5 years, have become a totally different company in the expertise of CAM manufacturing.
Okay. You know, can you talk about what Volumill has done? I mean, when you first saw it, you were a non-believer, and then when you started using it, you became a believer or an evangelist of Volumill, so to speak.
Well, I'm always a non-believer anytime somebody comes up and says, here's X, Y, or Z, and it's going to make everything so much better for you, but I'm always willing to try. We programmed the first part in Volumill. We did a test part. Actually, we did D2 and put it on the machine. We just grabbed a generic 5-flute half-inch end mill, put it in an ER32 holder, and we programmed it right around, I'd say, if I remember correctly, we ran a surface footage of 900 feet. We did a 1-inch axial depth of cut. We did a 7% radial depth of cut, and within 8 minutes, we had our first part done. The RPMs were fine. The machine spindle load was fine. So from that point on, we looked at it very seriously, and we were very diligent about watching our tool wear, watching our spindle load, seeing how the setups were affected. And everything that the company said they could deliver was delivered upon. And actually, we've turned it, and we've actually pushed the boundaries that the company sets out or advertises. Not all instances can we do that, but when everything's ideal, we can exceed even their parameters. The really nice thing about the Volumill, besides it doing what they advertise, it seamlessly integrates inside of Annex. It just shows up as another Toolpath. It handles the depth of cut, the radial, the speeds and feeds, just like all the other Annex menus. And a user that is halfway proficient at CAM programming with Annex, within 15 minutes can be doing a Volumill path. It's that seamlessly integrated. One thing that I think needs to be pointed out, that we have 6 programmers here at AFC. 3 of them are on nights. And of those 6, 4 of them are actually tool makers that are on the shop floor. And I was able to work with 4 of those tool makers that have absolutely zero experience with any kind of CAD or CAM software. Within the first couple hours, they were programming their own parts. And it is taken a lot of pressure off of the higher-end programmers. I'm actually quite amazed on how well they are adapting. And that kind of leads into the next item about the Volumill. The real beauty of it is, if you can see the software run, is I can take a program and I can run it on one of our full-blown 3-axis machines that has, 35 horsepower spindle and no problem. But when things get tight and I need to rough out a piece of D2 for a die detail and my machines are tied up, I can easily open up that same program, dial back my feed rates, and put it on a support machine. And when I say a support machine, I'm referring to one of our prototracks that's a 3-horsepower prototrack. And we can still run basically the machine at its full spindle capability, 120 inches a minute, and a 1-inch depth of cut on a 3.5 horsepower prototrack. So that has really freed up how we process the machines. So now we can have something roughed out and then bring it over to the other machines for finishing. That's another really nice perk that we didn't see and we just kind of fell into. Where it does morph very well. into basically any machine that will hold an end mill.
Great. And I think, Barry, I think you'll agree, the integration of the Annex CAD/CAM is a time savings, and then taking basically what Siemens has done and made machining really advanced, use volume mills an additional way to, different way of thinking on machining to enhance the toolpath. Is that a fair statement for you guys?
Yes, it's actually a fair statement, and if anything, it's very likely understated. The beauty of the volume mill integrated inside of NX is we're seeing model updates as they happen, or if they're required. So we don't have to worry about bringing a parasolid in, step file in, whatever you might have to do, and then reprogram or reassociate all the items. So you keep that associativity since we're integrated. What I'm seeing is a lot of my guys are using volume mill very heavily, even with inserted tools, even where if they don't want to use or they have a good setup to use an end mill, we're actually using on our high-feed cutters the volume mill instead of the cavity mill inside of NX. And the main reason is the volume mill paths we know are safe. There's no spikes in the material, no spikes in the spindle load, and it's predictable and safe. We can hit go and walk away. So guys are starting to use it almost like a cavity mill. We're not taking the exorbitant steps to cut, but we're still using the high-feed cutters. Kind of like currently right now, we've got a large piece of P20 that's on the machine. We're using an insert cutter. Instead of using the cavity mill, we're using the volume mill because we know it's safe. We've got approximately 13,000 square inches of P20 to come out of this block. So we're going to set it, and probably every 45 minutes, we're going to go back and check our inserts on our insert cutter and go work on something else. Again, because the path is so safe. That's kind of one direction we're going. Okay.
And if you guys would like to learn more about what Barry's doing, you can always contact me and we can get Barry on the phone with you guys. What would you say a fair percentage would be your savings? Probably 40% across the board?
I would have to say probably more like 60.
Okay. I think that's a significant savings, guys, when you think about your competitors. You got some room in a quote. You guys are close. If you can reduce that by 60% and put you in the ballpark, and obviously you guys can make deliveries a lot faster, make decisions quicker. Thanks, Barry. I appreciate it. Now we're going to get into Tim Banks. We're going to show the Annex CAM side. Just kind of do a broad brush overview demonstration. But like I said, we're going to hold the questions and answers towards the end. And we look forward to addressing any issues you guys may have, because you guys have different issues. And we'll see how we can help you.
Okay, Tim, you're good to start.
All right, thanks, Doug. I appreciate it. And then let me just become the organizer, and we will all get set. So before I get started with Annex CAM, I'm just going to play a video. We went to Sandvik in California for a volume mill event, and what happened was we decided to see, we took one piece of titanium and we did the same in half. We did one half volume mill, the other half we did with the conventional cutting method. So then we can just see the difference in how long it takes. So with volume mill on a piece of titanium, as you can see, it'll stop around here. It took about 5 minutes to do. And there's your finish time, 5:40. And then after that, we did that with the conventional method. All on the same day. We had this over lunch. We had all types of companies there as well. And here, as we start, we're already in 20 minutes, and we're not finished yet with the conventional method. So already, it's 4 times as much as the volume mill took. And again, it's great to see, customers talking about it and the sales guys talk about it, but then again, it's great to see it actually in motion and seeing that it does work incredibly, and to save right now, over 22 minutes off a part. If you're doing this part day in, day out, not only 8 hours a day, but with a night shift, think of how much time you're saving on one part. You're saving that 100 times a day. You're saving a lot of time and money. So there you go, the finished result, 5 minutes to 26. As Doug said earlier, it'll save you money, and you can make your money back pretty quickly. Also, Doug talked about learning advantage. Here's my learning advantage here. It's a great way. It's actually pretty cheap, and you can have anywhere. It does everything. I have CAD, CAM, CAE, and then in the CAM you can learn everything you need to know in NX, drilling, turning. You click on an activity, and then it lets you download the parts that you can use. So you can download the parts here, and then it has you can learn with videos and pictures the different applications in NX, and then it has activities for you to do to learn how to do it. And it's all just repetitive, trying to figure out the best ways to use all the tools in NX and how to use them. So pulling up NX, I'll move it over. The best part about NX CAM is that it is used, it's all in the same system. So if you have like a competitor software, you have to make it a step file and then bring it into your CAM. It's all built into NX altogether. So I can go from modeling here, I can go drafting over to CAE and manufacturing. So with just the click of the mouse, I'm in manufacturing instead of having to export it into a different program. It's all in line, it's all together. And what's also great about NX is if you make a change in CAD, so if I were to go back to modeling and just change one little part of this where the cutting path is, it will go downstream, and with the click of the button, it will update the CAM paths you've already made. So it's quick. Instead of having with a competitor, we would have to change basically some of them you have to change all your toolpaths again, but here it updates it automatically with the synchronous technology involved. And one great part about NX is you can go from 3-axis, which we have here, and I'll show. Here's a 3-axis cut. Pretty simple on this. It's the mold here. If I speed this up, this takes about 26 minutes to do. And then what's great about NX is called the 3 to 5-axis tilt, toolpath tilt. So what it can do is if you go from a 3-axis to a 5-axis toolpath, it allows you to, just with a wizard, it lets you just pick an angle that you want to tilt your tool at, and it allows all your 3-axis to go into more of a 5-axis tool. So it's a good kind of first step to getting into the 5-axis mentality. And I will show that back in NX. So here's the tilt. The tilt on this one actually takes a little bit longer, but again, with the angle on the side pass right here, with a little bit of a tilt, you get a better finish and a better angle. And if we go through quicker, this one takes about 33 minutes. And then if you go 5-axis, which I will show next, it's at 33 minutes there. 5-axis, you can tell the first thing you can do is if you look from 3 to 5, you can have a deeper tool path, as well as you can save time just by not having to reset this part over and over again. So just with, if you have a big aerospace part that you have to get, some big piece of machinery to move onto your machine, or even like a small medical part, if it takes some time to get it precise to beyond millimeters to make it, every time you have to zero off the machine, it takes time. If you have a 5-axis machine, you do it once, get it zeroed off, and you're done. Instead of this part, we'd have to, if it was a 3-axis machine, it'd be best to set it up on this side, cut these parts, and then set it up again on its side. It's better for a 5-axis just to set it up once and use all the angles possible to machine it and also to save time. And this one, I think the 3-axis took 26 minutes to do. This one takes about 17 minutes to do. So just with 5-axis, it saves half the time. And another great feature, just one that's new in Annex 8.5. If you're going across walls and cutouts, in Annex 8, it would have to go around the wall, kind of underneath it, and that just takes time. The tool has to figure out where it is and then go around the wall. In 8.5, which is new, for those of you who haven't upgraded or are looking to upgrade, it goes more of cut motion and step over across the gap, so it saves time just by not having to go as far, wrong part, across the path. So here we can see what it is in Annex 8. It has to take its time to dip around that cutout there. And then there's multiple different cuts you can do in Annex 8.5, where it kind of goes through the cut as if, not as if material were there, but it notices there is no material, but it can go around it, go through it more or less to keep it going. There's another example of that, of the different tools you can use, anywhere from cut, step over, multiple different things you can do. As well as with that, there's the floor cleanup. If you overlap the wall finish operation with the floor finish operation, it allows multiple passes. No, excuse me, it avoids multiple passes, which makes your machine time much shorter, which is, of course, that's what we're trying to do. You'll hear that a lot from Doug and myself. We're trying to save you guys time and save you guys money. That's all what NX and ViMill are all about. Here are some other milling enhancements that we have with NX. Some are new in 7.5 and all the way up to 8.5. One is a variable axis surface contouring enhancement. So what this does with the path, you can see on the right, there's just a lot of dots. That's kind of where that tells the toolpath where to go. It tells the tool where to go. In older versions of NX, there were just less points, so it's not as accurate. But with NX 8.5, you're able to get more. We're able to put more points in, which gets us a better finish and less time of generating the tool on more complex parts, as you can see on the left side. So again, saving time, saving money, trying to keep you all happy. Another new thing is for contour profiles, if we're looking at those impellers. So we get a cleaner, smoother path on this in 8.5 than we did older versions. So then there's different options you can use in your wizard for this. So you can either do an automatic, as you could do before, or you can align the tool to the edges and allows the tool axis to move between the straight wall edges as well as the swarf face. You can position your tool axis to align with the surface, and then you can use that to go between the blades. And one more great thing about what's new, and this is in 7.5, is just the finish on the blends of those impellers and turbines. It's a smoother finish and a quicker finish. You get full control over the entire cut area, so you have more control over what you're doing and how to make that blend and that finish as good as possible. And also in turbo machinery is the interpolated tool axis. And with this, you can see those colors, green, red, and yellow down there. When you're tilting the tool, it can decide what is a safe location for the tool and where there might be some interference. So it's safe when it's green, and if it's red, there's some gouging going on, and that's good to know. So if you're looking at the tool and you're looking at your part, you can see where the tool is going wrong and where you'll be okay. And just some more with NX, there's different roles you can do. So mine, it's all pictures. You might not know what any of these are, but if you're a beginner at NX, either CAD or CAM, you can go to an Essentials role where it gives you pictures with the words, so you know, okay, that's to simulate the machine. That's to see what the path is doing. So you can go from this, where it's nice to know what the tools are, or if you get used to NX for a while, you can hide those more or less and go for the bigger. I know all modelers, most CAM guys, we all like the big screen there to see our part the best and to use the most space as possible and keep all these buttons aside. And with NX9, which will be coming out soon, they're going to more of a ribbon toolbar, kind of like all the Microsoft Office products. And it will be a little more robust than Solid Edge. You can edit it, and you can edit like whatever. If you have tools that you use more than others, you can put them on the front page, on the front part of the ribbon, and it's fully customizable, so you can edit it whatever you want, and you can also go back to the original view that we have here. And then that will be coming out soon, I believe, and of course, when that does come out, we will have more CAD and CAM webinars and demos just to show off what's new in NX9 and all the new features and kind of tips and tricks of that. So with that, I will see if anyone has any questions for either myself, Doug, or Barry on either NX CAM, Vimal, how much time it saves, money, 5-axis, all of the above.
We do not have any questions at this point, Tim. If any of the attendees do have any questions, please type them in the question box, and we'll keep an eye on that. We'll stay on the line for another minute or two. We will also be following up with an email to all of the attendees with a link to the recorded webinar, and we'll provide Doug Gudorf's contact information in case anyone wanted additional information on Valley Mill or some of the work that Barry Davidson and his team are doing over at AFC Tool with NX and Valley Mill.
As well, if you come up with any questions after the webinar, feel free to either email myself, tim.banks@vmhinternational.com, or with that email you'll get, there's an info@vmhinternational.com. And if you send an email to that, it will be directed to either myself or Doug.
Okay, and we do have a couple questions coming in. One is from Robert. Robert, I'm going to go ahead and unmute you, and you'll be able to ask the question. Okay, Robert, you should be on the line. Hey, Tim, Robert's question was, is NX working on their own paths similar to Valley Mill?
That I'm not sure of. I can look into. Doug might have an answer for this, but I know as of right now, it's just an add-on in NX. I don't know if, Doug, do you have any?
Am I unmuted?
You're correct, yes. I can hear you.
Yeah, currently I just met with actually the CAM development guys, and yeah, it's on their radar screen, and they most certainly are trying to find something that does what volume mill is, or potentially acquire volume mill. So the answer is yes, they are looking into it.
All right, great. We appreciate it, Doug. And then we have another question coming in, and that is, can you show the interactive Toolpath tilt control for 5-axis?
Sure thing. All right. Can you be a little more specific on that, Kurt? Do you want to see like how it's done, or kind of just a 3 to 5?
Yeah, I'd like to see how it's done, and I would prefer to see it applied to a toolpath that isn't on the part that you guys have specifically set up for it. I like to try to break CAM software. So.
Oh, hey, I can't blame you. These are the only ones I have loaded on my machine right now. Actually, this is a loaner machine, so
okay.
I can get back with you, and I mean I can give you a call in a couple hours, and we can kind of take a look at that if you would like.
Specifically, what I'd like to see is, can you adjust the tilt interactively for just specific areas of the toolpath, or does that apply the adjustment to everything on the toolpath?
All right. That's something I could look into. I believe you can do each part, as you said. It's not just total. I think you can pick different parts of it to adjust different angles, and that's something I can definitely look into, and I'll send you an email or a call back with that.
Yeah, the Toolpath editor can do that.
All right.
Okay, and that's all the questions that we have coming in. At this point, we're going to conclude the webinar. We appreciate everyone for joining, and we will be following up with as we mentioned, a recording of the webinar along with contact information for Doug and Tim. And if you have any questions, please contact them directly.
Thank you, guys. Thanks, everybody.